is formula for semicircle. Anybody remember what that is for the area of a semicircle?
Pi times the radius squared divided by 2.
Yep. So that's our pi times the radius squared divided by 2. Based on the picture here, the radius distance from the center to the edge is 3 feet. Now that just gives us the area, right? We need volume. How do you calculate volume?
Area times height.
Yeah, take the area times the height, exactly. So we got area, we're going to multiply that by the height. Yeah. So area we can calculate, we got a formula, we got the radius, that's all we need there. Height, what do they tell us about the height?
2 inches.
2 inches thick. Problem is inches there and feet there. So we got to write the height as feet. So 2 inches, how would I turn that into feet? Yeah, there's 12 inches in a foot, so I'd say, well, that's 2 out of 12 feet, which we could reduce if we want to 1/6 of a foot. Yeah, so that goes in there for the height. Now, once I do that, area times the height, I'm going to have feet squared, right, from radius. And I'm going to have feet by the height. So what happens if I take feet times feet squared? What do I get? Feet cubed, cubic feet, which is what the bag of cement is measured in. All right, so figure out how much cement we need based on that. I'll let you guys play for a minute, and then I will share what I got. No, volume is feet squared times feet. Area is feet squared, right? So that's cubic feet. So area is feet squared, height is feet, so volume must be cubic feet. Nope. So we need to use bags of cement, right? Bags cover a certain amount of cubic feet. So we need to figure out how many cubic feet of cement are going to be in this patio, right? So that's why we had to convert the height in inches to a height in feet. Because it doesn't make sense to multiply feet by inches, it's got to be feet by feet. So these numbers here calculate the volume in cubic feet, so you can figure out how many bags you need. So give it a try, see what you got. We'll compare answers in just a minute. And I'll show you how I got mine. Anybody think they have a number? You got a number? Okay, so I'm going to show mine, and then I'll give you another minute to think about it, and then I'll go over how I calculated all mine. So I built a spreadsheet here. And so in the spreadsheet, I just made notes of what's my radius, what's it measured in, how do I do area, calculate the area. And I came down to a total of about $57 in the end. Includes the number of bags and the tax, because it says there's a 9.4% sales tax on this stuff. Okay, so those are my numbers. So play around with yours for a minute, see what you come up with. And then in just a minute, I'll show how I calculated those numbers. So I'll rebuild the spreadsheet. Daisy, let me know if you have any questions. Is anyone in the ballpark there on any of those figures? Not yet, Emily? That's right, we'll go over in just a minute. And those numbers there are based on what we started with here. Yeah, we got to cut it in half because it's a semicircle. It's not a full circle. Is that the part you're talking about? Yeah. Yeah, so the pi r squared in the top of the area here, that's the area of the circle. We just want half a circle. And just calculating the area is enough because we have to know how thick the concrete slab is going to be. And for if you guys ever do concrete slabs, don't pour them 2 inches. That's going to not be a good thing. It's going to crack first winter. Now it's making more sense?
Yeah.
Okay.
I remember
That half
the area.
thing, gotcha.
Yeah, I remember,
Yeah.
I remember trying to find the area. It's so nice. I think dividing by 2, I think.
Yeah, right, I get you. All right, so I'm gonna show how I built my spreadsheet. And I'm gonna have to come back to my picture here because it's impossible to do everything on a spreadsheet. I gotta sketch ideas on paper for me to figure out how to tell the spreadsheet what to do. So I'm just gonna start from scratch on the spreadsheet. So where'd the spreadsheet go? There it is. I'm just gonna bring up a new tab. Whenever, like I said before, whenever I make a spreadsheet, I like to write what I'm doing. So I'm making a semicircle patio. And so the thing I realized was important that I needed to know the radius of the patio. I'm just going to make a note that the radius is 3, and then off to the side, I'm going to put the feet. Usually you don't want to type 3 and feet in the same cell because then you can't use that in calculation. So if you want to use a number in a calculation, it's going to be a single number in a cell. Other thing I decided to put on here was the area formula that I need for this. And for me, area is equal to pi, I'm just going to type a pi, times r for radius squared, and then I have to cut that in half. So when I start typing that here, what do I have to type first for calculation? Equals sign, yeah. And then if I start typing pi for pi, it says, hey, you want the number pi? And Excel will do this too if you're an Excel user. If I just hit enter, it starts a parentheses. Now, usually on a spreadsheet, I have to put something in the parentheses. With pi, I just close the parentheses, and it just gives me the number pi. Okay, so I have pi times the radius. It gives as many decimal places as it knows, and the computer knows, like, I don't know, 15 or 20 decimal places of pi, right? So, which is a little bit more than a calculator. Do I need that many? Not really. I'm going to round these numbers later. Okay, you could just type 3.14 there, and that would be good enough. Okay. But if you forgot what pi is, the spreadsheet knows it up to a whole bunch of decimal places. So for the radius, I'm not going to retype it. I'm just going to go up here and point to it. In case I got it wrong, I can go back and retype it. So then I raise that to the second power and then divide by 2. And that's the right order of operation. So I hit enter. What are the units of that 14 number there? Are they feet, squared feet, cubic feet? What's that? Not cubes, yeah. It's just area, so it's square feet. Yeah, area is always squared something. So this one's square feet. And again, the reason is I squared the radius. Feet times feet gives me feet squared. So feet squared or square feet, whatever you want to call it. Okay. Let's see, what else do I need to know? I need the thickness of the pad or the height of it. And so the height, now the trick here is they gave me inches, so I'm just going to have the spreadsheet convert for me. I'm just going to take the 2 inches and divide it by 12 right there. And it says it's 0.16666. More decimals than I need, but no big deal. That's measured now in feet. So again, when you put numbers on the screen, make sure you say what they are and what the units are is a good idea. Now I'm ready to do volume, right? How do I do volume again, Elizabeth?
Area times height.
Yeah, so then I just go equals, click on the area, times, click on the height. Enter. 2.4-ish, right? And again, depending on how we used pi, how we rounded the height, we'll get slightly different answers, but you should all be in the ballpark. 2.3-ish, 2.4-ish, somewhere in there. What's the units for the volume? Feet cubed or cubic feet, yeah, because it's feet squared times feet there. So that's cubic feet. Okay, so I got the volume. So let's see, where are we at? Looking back here, we know the volume now. I need to figure out how many bags I need. So I'm just gonna make a note about the bags. Pounds, it turns out that's an irrelevant fact about the bag. I don't need to know that, okay? Except I'd rather lift a 40-pound bag than a 90-pound bag when I have a choice. But often cement will come actually in 90-pound bags. So I'm just gonna put bag here. And what matters for me about the bag is how many cubic feet of cement it's gonna make when I put the water in it. And they said 0.3 cubic feet per bag. Cubic feet per bag. All right. So would you agree, I want to know how many bags are going to fit inside that volume? Right? That's a division problem. Okay. If you're unsure of that, we could write out a fraction that'll help us figure it out. So at the moment, I have about, let's call it 2.4 feet cubed that I need to fill. I need to make a conversion factor where I want to get rid of feet cubed, and the cement bag tells me that one bag, sorry, this is getting messy, gives me 0.3 cubic feet. So they give me the conversion factor right there. So let's erase that stuff so we can actually read it. Okay, so they gave me the conversion factor. Oops, it's just a matter of applying it. So I have 0.3 cubic feet is one bag. So I can see here, if I divide by the 0.3, that'll give me an answer in bags, right? So when I'm unsure of what to do with some information, conversion fractions can help me figure it out. And I'm hoping that when you take the test next week, there's going to be conversion problems on there. You write some of these down for me to see, because it'll make me super happy when I'm grading the test, and you want me happy when I'm grading your test, right? No, yeah, it's good.
It's like one that I know, writing it down.
Yeah, so here, I know, so that's a good point. So Emily said, if it's one that I already know, writing it down sometimes confuses me. If you know it and you've used it before, just do it, right? Yeah. Yeah, but sometimes we have a lot of conversions to do to make something happen, and then sometimes the writing it down happens. So I don't expect you to write it down all the time, because like you said, sometimes I just know, hey, I need to divide by 12 here. But every once in a while, I'm in a fog and it's new to me, or it's just a bad day, I'm not sure what to do. This straightens it out. Okay, so it's a good tool. What's that?
I did mine on a different piece of paper.
Your work? Okay. Yeah, so on the worksheet, sometimes I'll say, hey, I wanted to see some work here. On the test, if you do stuff on a different piece of paper, give me that other piece of paper, because I really want to see how you came up with your answers. All right, so here, so what that tells me is now I can go for number of bags, maybe I'll call it, number of bags. And so to find that, what am I going to do again? I'm going to hit equals, then help me out. Not 0.3 yet. Look back at my scratch work. What number do I click on first?
4.
The volume first, then divide by 0.3 is what this tells me. Right, so that's why whenever I use a spreadsheet, I got to write stuff down on paper so I know what to do with it. So I need to take my volume, hit slash to divide, and then click that. All right, so I need to go to Home Depot and say, hey, can I have 7.8 bags of cement, please? Right, so we'll round that. Now here's a problem. I can tell the computer to round that by decreasing the decimal places I see, but it's not really rounding when it does that. Okay, so I'll just prove it right now. So underneath, I'm gonna take, how much is it per bag? $6.50? Yeah, so if I go, let's just make believe it's $6. If I take 6 times that number above, what should the answer be? 6 times 8 is 48, okay. What does it tell me? Yeah, so my point is, on a spreadsheet, when you tell it to show you less decimal places, it still remembers all of those decimal places. It didn't really round. It's just showing you what you want to see. It didn't truly round. How do I know it didn't round? That ain't 6 times 8, right? So you got to be careful about that. If you want it to truly round a number, there's a function called round, right? So underneath, I'm just going to apply that. So actual bags, maybe I'll do it underneath. So I just start typing the word round. It says, oh, you want to round a number. Now it's got the regular rounding, it's got always round up, and it's got always round down. And there are some times when I always have to round up or always round down. Like remember the fence posts? Fence posts. That one right there, because we already had corner posts, we were always rounding down. If it didn't matter whether a post was a corner post or not, we would always round up, right? So sometimes those are useful. So here I want to round.
With money, you always round up,
It depends. The banks have options. They can either just chop off the decimal and just push that to the side, or they can choose to round. And they can choose to do so whether it benefits them or you. And generally they choose to do it when it benefits them. Yeah, so, but usually in practice, like with accounting, we tend to always round down. Yeah, which is chopping off the decimal essentially. All right, so I round, I give it the number I want, and then I have to do a comma and tell how many decimal places I want it to round to. So I'm gonna hit 0 because I don't want any decimal places. I just want a whole number. When you're unsure how to use one of these, there should be oh, there's the question mark. The question mark, come on, tells me what to do. Why isn't it working today? Question mark. Ah, there we go. So this tells me, the rules of rounding. And sometimes I read what they say and I say, oh yeah, I get that. Other times I'm like, what the hell are you talking about? And then I go to YouTube. How do you use round on a spreadsheet? And somebody created a video, guaranteed. All right. So although the number above, if I show more decimal places, is different, the number below is definitely 8 now. So just be careful of that on a spreadsheet, rounding versus showing decimals. Okay, so now I can get the cost, because I know how many bags, cost of bags, worth of bags is, and so then I can go equals, take the actual bags times that 650. I probably should have typed on the spreadsheet, but I forgot. All right, and then I'm gonna say that's in dollars. So it's gonna be 52 bucks for the bags. I'm almost done. What's the last thing I need to do? Yeah, I gotta do the tax. So I'm gonna calculate the tax next. 2 ways to do it. One way is to realize how to turn 9.4 into a decimal. Anybody remember what 9.4% is as a decimal? 0.094. Yeah, so I could either type 0.094 times the number above, oops, to get the tax. Or I could actually type the percent symbol. So I could type 9.4% times, and notice when I did that, it said, oh, you mean 0.094. So the spreadsheet's smart about that now, times that number above. Either way, I'm gonna get the same number. So finally now I can get the total cost. So I just sum up those two numbers. So there's my total cost for this project. Questions on how I got that?
I couldn't figure out how to use my calculator with pi as radius, so I was doing the radius. The problem I had was I did my radius, and then I was taking the radius and times the radius for some reason, and I ended up with double and then half of it. So I was in it. So I had a mistake. I ended up with the right thing after I figured out what I was doing.
Oh, yes. Yeah. So, yeah, again, playing with a calculator spreadsheet always takes practice.
I did that same thing. I had to do the radius. And I squared the radius.
Yeah.
And I just divided by itself by 2. And then
Yeah. All right. So I think we've gone over everything. Okay, so either you're done with this now and you can give it to me today, or you need to tidy up a few parts and you can give it to me tomorrow. Thank you.
So what?
Yeah, no, and again, it depends on how you round it, right? So some of us may have answers that are slightly different than this, but we should all be around 50 something bucks. It just depends on how we round it where. But the one mistake we really don't want to make is about multiplying by 7.8-ish versus 8. Because, if we work for business and a check was cut based on the 7.8 number, we're going to go and not have enough money to buy that cement. because it's not a full bag's worth of money. So we got to be careful about that. So which means just we need to be used to when a spreadsheet actually rounds and when it's just showing certain in the decimal places, which just takes practice. All right, so my hope last night is you were working on this worksheet, that you were working on the 7 homework, which is due tonight, and that you took a look at the prep for lesson 8.
I was working on the prep and I didn't do the homework.
Yeah, and that's okay. Yeah, it's always better to focus on getting the prep done so that you show up for class a little bit prepared for what we're doing. And so you're not doing it backwards there. Actually, that's a good practice. All right, so we're gonna jump into that in just a moment. On that 1-8 prep. Yeah, we'll get to that in just a second. So before I do that, I'm just gonna take a peek at the 1-7 homework, which is right here. And so some of the 1-7 homework, oh, that's the 1-8 prep. Oh, I can't load 2 things at once. I forgot about that in this system. So let's see what I have to do. I have to close you. Close you. You can stay open. You can stay open. Over here, I have to start over. Yeah, interesting thing, the way this system hooks up with my other math system, you can't look at 2 different homework assignments at the same time in the same browser, which is kind of weird, but it's the way it is. All right, so let's see. That one's not too bad. Yeah, so here you're supposed to do some research online or in a book and come up with a formula for a triangle, and you're supposed to tell me what variables you used. Okay, so they give an example here of what it would look like. So you would tell me something like L times W is the formula, and then you would tell me what your variables meant in the variable box. So for example, for a parallelogram, let's see, for the area, which is going to go here, that's just, I would call it B times H. And then down here, I would say B equals the base. And then we want a semicolon. Let's get a little semicolon there. And then I would say H equals the height. And that's how I would type that in. And by the way, that is true. A parallelogram is a lot like a rectangle. If you know the height of the rectangle, and the height is just the perpendicular distance to the base, then you got yourself the area. So I'm just going to draw that in here for fun. So parallelogram is a 4-sided figure where a 1 pair of sides is parallel and another pair of sides is also parallel. Right? So it's got 2 sets of parallel sides. And if we claim that this is the base down here, then all we need to know is the height. And the height has to be perpendicular to the base. Okay, so this black side over here on the left, that's not the height. The height has to be measured straight up from the base to the top. If I know those 2 numbers, I know the area. One way to think about that is if you were to slice off vertically that side and pick that thing up and stick it over here, what will you have made? A perfect rectangle. Yeah, so every parallelogram can be, with 1 chop and a replacement, be turned into a rectangle. In which case, you still have the same base and perpendicular height there. All right, so I'll let you guys attack that later if you haven't already. All right, anything else of interest here? Not too bad. Not too bad, kind of like the worksheets. Again, like the worksheets. All right. So let me know tomorrow if you have any questions on this. We can go over it. So you're supposed to try and finish this tonight if you haven't already. What's that? Oh, I'm not going to be here tomorrow. Yeah, so if you have any questions on this, then you can hit that Ask Your Instructor button right here. And I'll write back to you ASAP. So get into that homework, check it out. Let's check out 1-8. Let's see, to do that, I have to go back home. Close 1-7 stuff. And and find 1/8 prep. So Emily, you have a question about 1/8? Which one?
2 and 3.
Okay, so 2 and 3. All right, cool. Let's play around here. And let's see. That always looks like that. What I can do with that? Let's take it into a new screen. Shot it here. All right, so this is just hopefully a review, although some of these can be a little bit tricky. So I just want to remind you a couple of things about percentages before I fill this out with you. And we talked about this earlier in the class. Percent. So per in math means what? Divide, yep, it means divide. And cent means 100. So percent literally means divide by 100. So consider the symbol for a minute. This right here is the slash for division. And these are the 2 zeros of 100. So all percent symbol is a shorthand for writing, hey, I have a part of 100 here. So if you think about my grid over here, this grid is 10 by 10. So there's 100. So if I shade part of this grid, like let's shade those right there. All right, what part of the grid did I look at? Well, I tried to shade 15 squares. There's a total of 100 squares there, so this must be 15%. All right. So when you see a percentage, you can just literally trade that symbol for divide by 100. From there, you've got 2 options. You can whip it into the calculator and do division. Use the shortcut that if you divide by 100, you have to shift the imaginary decimal place here 2 places to the left, or just reduce the fraction. So for example, 15 and 100 have what as a common factor? 5, so I could take 5 into each. So 5 goes into 15 3 times, 5 goes into 100. 20 on a good day. So 15% must be 3/20. Anybody with a calculator nearby, whip it out, type 3 over 20. Does it give you 0.15 back? So to change a percent to a regular number, percent, to what I call a regular number. Now a regular number, either I mean a decimal or it could be a fraction. Okay. All you do is carry out the divide by 100. So that's how you convert percents to regular numbers. If you want to go the other way, if you want to take a regular number, that number could be a decimal or a fraction, and you want to convert it to a percent. What's the opposite of dividing? Multiply. You just multiply by 100. Okay. So let's take a number we're all pretty familiar with. We all know the number 1/4 very thoroughly. Okay. So if I wanted to take the number 1/4 and change it to a percent, all I would do is multiply it by 100%. That's the other trick there. We're not just multiplying by 100, we're multiplying by 100%. 2 options. I can just plug this into my calculator. What's 1/4 of 100? Or maybe I can just figure it out in my head. Multiplying fractions, you could say that's 100 over 1. So my numerator is 1 times 100. My denominator is 4 times 1. 4 goes into 100 how many times? 25 on a good day, so that must be 25%. So getting rid of a percent, we have to do division. To make something into a percent, we have to do a multiplication by 100%. Right? Then it's a matter of just cleaning up that math with a calculator or by hand. So based on that, let's go back and fill out that table.
You could almost just do the 1/4 times 100 and then just put a percent behind it, right? 'Cause wouldn't that-
Yeah, that's the same idea. Yeah, exactly. All right, so where's that? Over here. Okay, so you guys are going to help me out with a calculator. So here, just a note, simplified fraction. Decimals, we often read it in slang. So I look at that decimal up here and I say, oh, that's 0.01. The proper way to read it is to name the place value. So I look at it and say, okay, there's my tenths, there's my hundredths. So that's really 1/100th, which is what the fraction tells me. So here I have a tenth. I want to change it to a percent. So do I multiply or divide to change 1/10 to a percent? Multiply, good answer. Yeah, so what's 1/10 times 100%? What was that again? 1/10 of 100. 10 goes into 100 how many times? 10 times. Yeah, that would be 10%. Yeah, so I'm changing it to a percent. I think you were thinking of the decimal answer. Yeah, as a decimal, it would be 0.1 as a decimal. What's that? Yeah, so to convert a fraction to a decimal, you just do the division. And this right here says to take 1 divided by 10. Exactly. Okay, 0.2, that is a regular number. I want to convert it to a percent, which means I need to multiply or divide by 100. Multiply, okay. So I have to take 0.2 times 100, which gives me 20%. Now, reading this properly, what place is that 2 in? It's in the 10, so that's 2/10, which Aaron said reduces to 1/5. Yep, thank you, sir. So that would be 1/5. Yeah, so you're supposed to just go through each of these and try and rename them as their, now the simplified fraction and the decimal are going to be directly related. But the percent's going to be a slightly different number because we're kind of pulling out that 100 version of it. Let's jump to 2/3. It's a little bit trickier. So 2/3, I got to multiply by 100%. So let me bring a new page. So 2/3 times 100%. If you just whip that into your calculator, it gives you 66.66666666, right? And it said there to round. So calculator-wise, the calculator would tell us that this is 66.666. Eventually, most calculators will throw a 7 in there at the end. And let's see, where were we asked to round? To the nearest 1%. So looking at this over here, did I get that right? To the nearest 1%, yeah. That means they want me to round right there, so I would call it 67% is what we would say. So I'm going to write curly there, and approximately. So I would say it's approximately 67%. It's missing a little change, but that's okay. Without a calculator, just for fun, I could view this as 100 over 1. And when we multiply fractions, we go straight across the top, straight across the bottom. So 2 times 100 is 200. So I need to take 3 into 200. Usually in a situation like that, I whip out long division. 3 goes into 200. Let's see, 3 goes into 2, it doesn't. 3 goes into 20. 6 times? 6 times 3 is 18. And then I subtract, and I get another 20, right? Which means I'm going to get 6s forever as I do this, because it's going to keep giving me a 20 and another 20, right? So I can kind of see it starting to come, 6 times 18, subtract, 2 remainder. So if I just pause right there, it says this division right here is 66 2/3. percent. So it is possible to state it exactly by just doing division. If you whip it in your calculator almost always gives decimals. Anybody have a calculator with a fraction button? Yeah, those are nice. I love using those. If you don't know how to use your fraction button, let me know. I can help you with it. But those are really sweet. It saves you from having to do long division, which unfortunately most people don't like. Which is
How do
sad.
you turn 1% into a fraction?
What's that?
How do you turn 1% into a fraction?
So here I just changed the fraction into a percent. Okay, so I got a couple of answers here. One, I could say 2/3 is exactly 66 2/3%. The answer on that screen, they said, give it to me to the nearest whole percent, which means I would enter 67 on that screen. Oops, wrong way. So here I would type just a 67 right there.
But on the last one, though, I did.
Yeah, we'll get to that, hang on. What would I, 2/3 rounded to the nearest hundredth, what would I enter? 0.67, yeah, 0.67 is what we'll do there. Okay, so you're asking about this one here, Emily, is that right?
Yeah, because the other one like that, I knew that.
Yeah, so bottom line is, how do I change a regular number to a percent? Our rule is to multiply 100 by 100%. So if I write that down, new page, 0.75 is a regular number. I need to multiply it by 100%. So you could just ask your calculator to do that, or know that multiplying by 100 shifts the decimal point 2 times. So the answer should be 75%. Okay. How do we change a decimal to a fraction? We just read it properly. What place value is that right there? So this must be 75/100ths. Are there any common factors, top and bottom? 5, okay. Or, anybody see another common factor?
25.
Yeah, if you think about dollars and cents, quarters, 25. How many 25s are in 75? And how many 25s in 100? Yeah, so 3/4 would be the simplified fraction version there. Yeah. If you happen to have one of those awesome calculators, you can just say, give me this as a fraction, and it will just tell you 3/4, which is pretty cool. I don't think my iPhone does that. But I think my Desmos calculator might. I'll have to test that later. I didn't bring my phone with me today. All right, so let's see, we're almost out of time for fun with math. Let's take a quick look at the worksheet. So I mentioned yesterday, I'm going to go to a conference tomorrow, so I won't be here. So my goal, I said yesterday, was I was just going to look at wherever we got today, and then I'm going to make a video right after class going over everything else I hoped to get done today and tomorrow. So I'm going to make a video that covers everything you need to know about the worksheet for 1/8. Did I give you guys copies yet? No? Okay, those of you in the room, here's a copy. Daisy, I wish I could teleport you a copy, sorry. This room will be available to you if you want to come here and work together. I highly recommend that. Otherwise, what'll happen is, if you look at the home page of our site, a couple things to note. This top spot that says Math 98 course information, oh, that's the wrong name. It's supposed to say Math 62. Somebody told me that in the first day and I forgot to change it. Yeah, sorry about that. There's a YouTube playlist. Any videos I create for this class automatically go into that playlist. So you can look there. Otherwise, when it's specific to something we did, I usually take the video and I'll add it right to it. So I'll add a video to this page right here after class today, after I record it today. So probably later this afternoon, that'll appear there if you need help. Stuff that you're going to do here, it's just getting used to percentages. And things that are important with percentages are, can you look at a percentage and make an educated guess about, where it's going to end up? Like before, when we had the tax on the concrete, it was 9.4%. 9.4 is close to what nicer number? 10. 10% of a number is great. I just shift the decimal place once. Okay, so that's an easy thing to do. So the first part of this page is just how would you estimate some of these percentages here, right? Not plug it into a calculator, but could you look at that and guess at about what the answer is? Right, so like, let's pick on this one here for a second. 33% is close to what? 30% maybe, yeah. Or somebody else might say a third, right? And then 59 is close to what? 60, yeah. So I might say, what's 0.3 times 60, or what's a third of 60? And that's a way I could estimate that right there. So here it says give 2 quick ways to find an estimate of this. So by estimate, we mean not whip out your damn calculator, which, you know, we all love our calculators. However, it's good to just have those skills. So just mess around. If you can only find one way to estimate it, that's okay. Just write one way. But try to find 2 different ways to estimate without a calculator. Otherwise, it's knowing some just, you know, ways to rewrite things as a fraction and a percent. We were just playing around with that. And then applying those percentages. So at first it's kind of straightforward, but then it gets a little trickier. Like number 4 is kind of an interesting question, and so is the cash back one. So my video will mostly have stuff like number 4 and 5 in it. And this one's actually relatively short. It's only a few pages long, so you get through this one pretty easy. We're scheduled to take a test next Wednesday. There's a good chance I'm going to put up that test till Thursday. We'll see how the next day or so goes. And what are you going to do if you get stuck on any homework questions today or tomorrow?
Press the button.
Press that message my instructor button. Yeah, I'll be checking my email regularly. I'll get back to you. All right. Have a great day and a great weekend.
718, and then